One, and you don't have a normal lecture from the book scheduled for tonight. It said to be announced, and what I decided to do was show you how to collect data from an Android machine. This is the first batch of extra credit projects here. There's 2 of them. So let me fit this on the screen better. There we are. We're down here. So it's going to be these 3 projects. I'm just going to demonstrate them, and then I'll just answer questions that come up. M140, M142, and M143, where you set up an Android device and you collect the forensic evidence off it. So, why didn't I stay in the warm room? Well, they turned off the heat in the warm room and the projectors are all broken. So it began to lose its value. The projectors are what really made it impossible to stay in the warm room. I can hunt for more warm rooms. In fact, there's another one I can think of in that building that's available some nights. That might be the next thing to try. Anyway, this is the only solution for tonight. It's always like this. So let me get the... Now, I'm going to be doing this on an M1, but it's very much the same on every operating system. Oh, I don't need this, pardon me. We're starting a Windows 11 machine by accident, but I'm not going to use Windows 11 right away, not till later. I think I'll close it for now. The first bit, you use Android Studio. So let me bring up the instructions here. They're at the bottom here. You'll see a series of these. 140 is Android Studio emulator, then rooting the emulator, and then doing a forensic acquisition from Android. And these are all extra credit because this is somewhat out of the path of using autopsy and stuff, but this is the process that collects the data from the phone, and it's a good thing to know. So the first thing is Android Studio emulator. This is a really good product, a free product from Google, and it really gives you a good simulation of Android phone now. It used to not, but they've improved it greatly. And I used to use a bunch of other emulators like Genymotion, but those are really flaky, and this is now the best way to do it. So you install Android Studio, which install it not in a virtual machine, but right on your host machine. And it run on any operating system, but it requires real graphics, so you can't run it in a virtual machine. It won't settle for simulated graphics. And it'll start up. Let me try to make it fit on the screen a little better. There we go. All right, so once you've got this Android Studio, it lets you write Android apps and run Android apps. So I'm going to make a new, just to demonstrate the process, I'm going to make a new project, because this is what happens when you start it. You have to tell it what type of Android project you want to make. And the one I found that works is Google Pay activity. I thought it said Google Play when I first did this, but Google Pay works. See, some Android images allow you to get the Google products like Google Store and Google Maps, and others don't. And this one does, of course. So anyone that lets you get the Google Play would probably be good enough. Well, for what we're doing here, you might not even need that. But in the Hacking Mobile Devices class, we need that. So I'm going to call this CNET 121 demo. All right. So I made a project of some kind, and I'm going to delete this old phone, which I made earlier today. I'm going to show you how to make a new one. All right. And so let me bring the instructions onto my other screen so I can follow them while moving forward. Okay. So, I seem to have 2 copies of Android Studio running somehow. There, I guess when I made a new project, it created a second window. Anyway, there's my Android Studio, the one called CNET 121 Demo Good, which is the one close to what you're going to see. All right, and now there's yet another window somehow. All right, so, the first thing you got to do after you've created a project is now create an Android phone. And so over here, you got a thing called Device Manager, and in here you can create a device. And now you can choose various types of devices, and the one I found that works, they don't all necessarily work, especially on the M1. They really don't all work, but I think 3A works. The ones with an arrow here are the ones that are going to have Google Play Store, which is a good thing. Then you can install real apps on your phone. And so I start with that one. Next, the next one is really important. This chooses what version of Android to use. And versions of Android come in 2 numbers. There's numbers here going up to like 12 and 11 and stuff. And then there's subversions, which are these API levels. And not all the API levels work. In particular, if you're using an M1, the only one that seems to work is API level 31. Because, you know, they give this product to all operating systems, but it's not up to full functionality on every operating system. So for most of them, you do API level 30, but on the M1, you have to use 31. Anyway, it doesn't make any difference for what we're doing. We just need an Android that works of any type. But if you choose the wrong API level, the emulator will not run. Now, this gives you a default emulator, and the tutorial I followed said to give it more, show advanced settings and give it more RAM, which I've always been doing. I've never had the energy to go back and test whether you really have to do this, but they say give it 4096 internal storage instead of 2024. So I just do that because that works. And there I finish. And now it has created a device. It's just sitting there right now, but I can start it. Now, by the way, if you're using the M1, there is an adjustment you have to make where you have to go Android Studio Preferences. If you're on Mac or Windows, you probably don't have to do this, but here in Tools Emulator, there's a little box called Launch in a Tool Window, and you have to have that unchecked on an M1 or it won't work. So after you've done that, now you can run it. This is the run button. This is a lot like the virtual machines you've been using, virtual Windows machines and such, but it is a virtual phone. And there it is coming up. There, you see it's booting up correctly, showing the Google logo and all that good stuff. That's good. If you've chosen an unfortunate combination that won't run on your hardware, then you'll get some kind of error message or it'll just freeze and never boot up. All right, so now, that's right, I do need Google Play for what we're doing here for the next step. In fact, even to get the flag here you do. So for the flag, I wanted you to install a terminal emulator. So you have to go into Google Play, and you have to sign in with a real Google account. It can be any Google account, doesn't matter. I've made a throwaway one just for use in Android emulators because I use a lot of them. And we'll see if this thing is going to connect or what. Good, it's connecting, good. So I put in my throwaway account and a password, which I found earlier today, and perhaps I still remember it. Evidently, all right. So now I agree to the terms of service. This is an account that doesn't tie to any of my personal data. It doesn't have a credit card in it or anything, which I recommend if you're going to do Android security audits, which is mainly what I do here. I'm going to turn off the backup. I don't want it backing up data from this phone to some Google account. That's nonsense. This Google is just for temporary test projects. That would just be a waste of time and storage. All right. So now I get in here. Now I'm in the Google Play Store, just like you would if you have an Android phone, which is the equivalent of the Apple Store. And I wanted you to install Qt, Q-U-T-E, which is a terminal emulator, lets you just execute terminal commands right on your phone. And you'll see there's something else with some other name, but here's the one, Qt Terminal Emulator. And you can install it from the real store if you have logged into a real Google account. And I have, so I can open it. And now I can execute commands here, but I do have to go through a warm-up process. I have to agree to something, and I have to continue past this and grant some permissions, allow it to access files, and then go back. And now I can execute commands. And so the command I need is uname. Well, I can do all the usual commands, like ID will work. ID will tell you who you are. I am user ID 10147, and if you take the Android course, we talk about this. Every app runs under a separate user account. Anyway, uname. Whoa, looks like it crashed on me or something. Let's see. Nope, I must have just hit a funny key streak. Let's see. All right, yeah. So now, if you do uname minus A, is that what it is? Shows your operating system. Let me check. That should do it. I have to hit the check mark. Enter doesn't work. There you go. Then you get what version of Linux you're running. And Android is Linux. It's close to Ubuntu Linux, close to Debian. All right. Anyway, so now we have an Android device, and that's it for the first project of the ones I wanted to show you. That's all this first one is, getting your Android device running. Now, the next thing is you need to get root permission on your Android device. By default, if you have a phone, the very first version of the iPhone, actually everybody was root all the time. But there was no app store, and there were no apps. So they weren't worried about the security consequences of that. Now let's see. What if I have an old Android phone? You can try it, but I would recommend using the emulator. You'll probably have better luck. An old Android phone, the root here might not work. So now we have on all modern phones, you are not running as root. And they don't want you running as root because they'll mess up the operating system. And if you do, you void your warranty and they don't want to help you and all that jazz. However, people do it all the time to hack their phone, most commonly to put on pirate apps that they stole, that they get from a store, and other purposes. And if you want to do a forensic examination of a phone, you definitely want to be root because you want to copy all the data off the phone. And if you're logged in as just one user, you'd only be able to get that one user's data. Well, with Pixel 3, you might be all right. Try it and see. Anyway, so we're going to root the phone. That's the next project. And let me bring it up in my window here. Well, I got it here. So to root it, there are a lot of different ways to root a phone. And these are all just hacking tricks to hack a phone. But one of the really nice ones is Magisk. Magisk is a nice tool designed to root phones, and it works on a lot of phones, and it works on the emulator, which I was very pleased to discover. So what you have to do is now the way this works is a little screwy. Let me open it here so I can point to these. All right, what you have to do is you're going to replace the memory of the phone. The memory of a virtual device is just a file on your drive. And you can replace it with a hacked file, and that's how this works. That's how a lot of hacks work, by replacing the memory. So the memory of the phone is in a memory image file. And from this root AVD Git repository is a script that will copy the memory image of the phone and add extra code into it and put it back. So when you boot it up, you now have the commands you need to become root. This works, by the way, for Windows too. There's a product called Conboot that does this. You can boot from a floppy, and you can be any user on the thing because it replaces the user in RAM. So even if you don't know the right password, you can get in somebody else's account that way. Anyways, this is what we're going to do. First, you have to git clone this, and you can do that on Mac or on Windows. You download the zip file and unzip it, and you'll get these things called root AVD. Now, I've already done the git clone on this, so let me make this go to a terminal. So on the host machine that is hosting the Android device, which in my case is a Mac. Let me get my Windows set up here. Okay, so still working on getting my window to fit. Still working getting my window to fit. All right, so now I seem to be in the right area. All right, I'm gonna go up here. And yes, all right, so ls minus L. I've already executed the git clone. When you do a git clone command from a URL that goes to a GitHub repository, it takes the entire contents of that code repository and puts it in a folder with the name of the program. So there's a folder called root AVD, and you have to go in there. After you clone it, you go in here, and you'll see there are apps, a directory of apps, and things like a license and something called magisk.zip. And there's a root AVD script that runs on Windows, the batch file runs, and on Linux, the sh file runs. So, all right, now you have to connect to your device with ADB, which this part will be actually, it might work, all right, ADB, and I think I have some clues if ADB doesn't work. You may need some help when you're doing this if you want to do ADB, because I think the Android Studio doesn't connect the path correctly. I've got it fixed on mine, but students may have a little more work. ADB is the tool to connect from your host to the phone, Android Device Bridge, and our GRUG bridge. And so if you do ADB devices, it shows you I have an emulator attached. This is what you must have. And now, once you've got that working, then you can use root ADV. And here's root AVD. This is the command. What this is going to do is scan my computer and find all the Android phones, all the Android emulators that I have connected to my device. And it's going to give me the correct command line to do various things. And I know I made this thing with API 31, which is what you see here. And there's a series of commands. The one you want is the one ending in ramdisk.image. What this is going to do is replace the ramdisk.image with a hacked ramdisk.image. And this is going to do it for Android 31, ARM64. Now, let me show you how I verify that that's the right one. I go to my emulator, my Android Play Store, Okay, and here, if I just make this window bigger, it tells me right there, this is API 31 and it's ARM64. So that's the processor and that's the API level, and that's how I know which command I need to execute here. So this is the command you need to execute. That's why they give them all to you here so you don't have to type all this out. This will create a hacked RAM image. Now, I think it's going to fail because I've already done it on this machine once earlier today, and we're going to see. If it fails, I'll show you how to overcome that. If you have to do it twice, there's a file you typically have to clean off, but we're going to see. So it's checking for things, internet connection, checking RAM disk status. It detected this boot image. And I think they might have fixed this because it might just work. Before, I had to go delete the hacked file. Now, what is this garbage popping up all the time? Guess nothing. All right. We'll see if it succeeds or what. Well, seems to be just freezing up on me, which is not right. After decompressing, Magisk will work, detected format. Well, all right, now the way you fix it, here we are. This is my system images. This is what I had to do before. I had to delete this file to make it work when I did it a second time before. And I actually got an error message. Now, for some reason, I'm not getting an error message, so let me just try that. If I make a new window, because I'm going to have to go to this goofy directory, and I go to that directory I just copied, which is where the actual RAM is for this device. Now I do an ls. Here's the RAM disk.image, and there's the backup. So I want to get rid of this one. It found a RAM disk there, and it detected it was not a clean RAM disk. This is the problem. It expects to find a clean phone that is not rooted. If it finds that the phone is already rooted, it freaks out. And I think, because I've already done it once, it has an old image. So what I'm going to do is I'm going to move RAM disk.image to RAM disk.image bad. And then I'm going to move the backup. See, when it does the hack, it takes your memory and it makes a backup of the original memory. You always want to do this whenever you're doing hacks because they often ruin everything. This is the hacked version. So I'm just moving the existing hacked version out of the way, and I'm moving the backup to the original. There. Now it should have the clean original RAM, and therefore this command should work. Let's see if that's true. All right. So there it goes. All right. Aha, it moved. Okay, that was the problem. It only happened to you if you do it twice on the same device. All right, so now it has done it. So it's going to try to shut down the AVD. There it went. It turned off my phone for me. Now you have to do a cold boot of your phone, which will boot into the modified RAM. So cold boot now. And here's the emulator telling you cold boot requested by the user. This is good. All right.
When you start the cold boot, what software are you using here to kick?
When I start the cold boot, what?
When you start cold boot, you click the button. What is that program?
I don't know. You mean the message that popped up? I don't know what that is.
You go to that program to kick this cold boot startup, right?
No, you go into the Android Studio. You boot it from there. Yeah, you boot it from there. And actually, I don't really understand how it uses the RAM image. I don't quite get it. But anyway, it boots from there. And now it has this program called Magisk. And now you can try to elevate yourself to root, which you do here. Okay. Now what you have to, now go to your command line. And ADB is what you use to execute command line commands on the phone. And you have to adjust this so you can see the phone, because here you have another mistake to make. You're only going to have 10 seconds to approve this. This is how most roots work. Rooting your phone, in the early days, people would root like iPhones. And when you root them, you would put SSH on them, and anybody could connect to them and had a default password. So people keep getting their phones infected and hacked. So now they have security measures, and in Android, they mostly do it this way. When you put a root on your Android, it will pop up a box asking for permission to run as root, which is how you prevent somebody else doing it to you without your permission. So I connect with ADB shell. Now I have a command line on the phone in the emulator. You can see the prompt here, but I'm not root. To become root, I do SU, super user. And now it pops up a box asking for permission, and I have to click grant within 10 seconds. If you don't, then you'll have to hunt through some stuff. I have some bit in the instructions how to fix it. But now I'm super user. Now I have root privileges on the phone, which is what you need to copy the forensic data off the phone. So
What other things you have to do if you not pass the 10 seconds to grant the permission?
yeah, if you missed that, then you have to launch Magic here as an app and then adjust some things inside there. All right. So anyway, now I have root on the phone, and there's a way to get a flag here. So this is the second project. And now I just want to show you the third project, and that is how you get the data off the phone. We used FTK Imager to get data off Windows machines and off registry and stuff, but I couldn't find any similar product that would work on Android, so I'm just doing a logical acquisition of all the data with plain old Linux commands, which works. First we're going to put some evidence on the phone, and this I thought was kind of fun. You can send phone calls and SMS messages to your simulated phone. All right, so I'm going to exit out of here, and exit out of here. I don't need this window anymore. All right, and so I'm going to go home, and then when you install Android Studio and you make an emulator, it opens a listening port to receive phone calls and SMSs simulated. And to protect your security, it protects them with an API key. So you have to, this is called emulator console auth token, so you have to copy this thing without taking the funny % character at the end. I don't know what that's about, but that's not part of it. And now you can connect to your phone on port 5554 with Netcat. So localhost and 5554. And now it needs my authorization, which is the key I just copied. Now that's rude. Well, maybe I do need a stupid %. I tried it earlier and I didn't. Auth. All right, what's going on here? Auth. There's a U. There, I'm in. Okay. Somebody saw I missed the U. Good. All right, so now I got it. Now I'm in. I'm authorized. Now I can send an SMS to my phone. Let me bring my phone to the front. There it is, my phone. All right. So now let me just get the instructions on the other screen so I can see them. That's not the right one. All right. Let's get the phone and the command line. All right. Now it's SMS send. Send an SMS message. And then I give it the from address, which I'm going to use the phone number, 222-3333, and then I put in the data. Hello phone. There. Now an SMS pops up. You got an SMS. So I can click that. I think that'll open the Messages app. Now I can see it. I can answer. All right, so now I've sent some SMSs, and this is the kind of evidence you're going to want off the phone. And you can also ring the phone, which is GSM call. And again, you have to get the from number. So I'm just putting 111-222-3333, and the phone rings. So you can answer the phone, and I don't know how to record the voice or anything, but I'm just going to hang up, but now it should be record that there was a phone call on the phone. So this is putting some of the data on the phone. And now we're just going to collect the user data. So what we do is we get out of this with Control C, and we do ADB shell again, and super user. Now we are the root on the phone. Now we can execute a command to just copy the data off the phone. And what I'm doing here, I tried this a lot of ways, and I finally went back to just really simple stuff. tar is just a command that will gather files and put them in a file. So it's this is going to copy the data from the phone and put it on the phone itself in the SD card download folder in Android image.tar.g. It's going to copy everything in the /data directory, so it's not going to bother copying the Android apps, the Android operating system. It's just going to copy the data from all the apps. Everything's in the /data directory. That's all the apps, including the SMS and the email and the phone calls and everything are in there. So this is what you just want the copy of this one folder. Just going to copy it and put it in a zip file, tar.gz, a Linux compressed file. So that's it, and it'll take a minute or two. It's just copying all the files that contain all the personal data from the phone in a very simple way.
Is there a way from the phone to get to that data directory?
No way what?
Is there a way for the phone to get to that data directory?
Sure, the phone is using that data directory every time you launch an app. The phone is always going in there.
But is there a way to look at the files in that directory?
Oh, sure, you can CD into them and LS them, and we did it all the time. On the phone, oh, you have to install a file explorer, and I think they mostly won't let you look in it at that level. Only if you root your phone, I think. Remember, they try to make it hard. Same thing's true of iPhones and iPads. They try to make it hard to get in the file system. So they don't like to expose the data directory, I think. No. All right, so now it's done. Now, you have to get the data onto the host machine here. Now I have to move it to a Windows machine for analysis. So I exit out of here and exit out of here. Now I'm off the phone. Now I can go somewhere like, I think I made a directory for it here. CD 121. All right. LS. Oh, I probably 128. Yeah. And, well, I'll just make a directory. I can demo. All right. All right. Now I can pull the data from my phone with ADB again. So there's ADB pull. You can pull data from your phone with SD card download. I'm just pulling that zipped image of the phone. And there it comes. You see it's really fast in this nice simulated network here. So now I have an image of the phone here. It is, if I do ls minus lh, I can see in human readable terms how big it is. Okay, it is 823 meg, about 1 gigabyte of data from that phone. All right, now I want to put that in Autopsy. So I got to start up my Windows device. And that's here. All right, and now I'm done with Android, so I'm just going to close that. If I can find the close button, strangely gone. Oh, here, okay, good. All right, so here's my Windows device. Now, I had a pretty pickle here. VMware Tools, why is this not moving? All right, VMware Tools does not work on the ARM version of Windows. You cannot copy and paste files in. So I messed around a little bit and I found the best solution is SCP, which is a native tool in the Windows PowerShell. So you can just open Terminal, which gives you a PowerShell window, and you can download that data with just a SCP command. So this I was very pleased to figure out as the best solution. I used to use a product called WinSCP, but it runs incredibly slowly. It was going to take like hours to transmit the data. And you'll see this is nice and fast. So I got to put the evidence on the phone, and there we are. I made a box of this. This is the command, SCP. Now you have to give it your username and the IP of the Macintosh. So let me do that. I'm Sam Bound, and let me get the IP of my Macintosh. If I go to my, I want an IP that the Windows machine can reach. So let's do ipconfig. All right, the Windows machine is 192.168.121. And so if I go to my Mac and I do ifconfig, I have a lot of adapters, but one of them is 121. So if I get tired of this nonsense, I can use grep and look for 121. All right, and there it is. It's this one. So when you do that, I want to do, in grep, you can do -B4, 4 lines. So now I'll get, there we are. It is, tells me which adapter it is, bridge 101, but actually all I needed was the address. It's 121.1. So I do have an adapter that goes to the Windows device with that address 121.1. So the command to execute is, I get my instructions back, which have vanished somehow. There's my instructions. All right. So I'm going to put them on the other screen so I can see them and get back to my Windows device, which is here. Good. So let me make my font bigger if I can. This is the new terminal, which appears to have taken away this. Under Control Plus would work. No, all right. Well, all right, I guess I'll leave it this way. That's Microsoft, of course. They're real proud of this new terminal, but they appear to have taken away the ability to change the font. All right, might be good enough. I noticed these videos are a little better than I thought they would be. So let's do SCP. Okay, I want to get username is Sam Bound at 192.168.121.1. And then you got to give a colon and the path to the file, which is users Sam Bound down, and now I got to figure out where I put it. So let me see where I am. PWD. All right, I'm here. 128, 121 demo. Okay, 128, 121 demo. And then I need the name of the file, which is android_image .tar.gz. And then that's how it's going to pull it, and where it's going to put it is just right here, dot. Put it in the current directory with the same name. So that should move. Now it needs my password for the Mac. And I fouled it up somehow. Users Sambound. Okay, let's see. What's wrong with my directory? Users Sambound 128, 121 demo. Oh, I've got a W instead of a S at the end of users because I can't see what I'm doing with the small font. All right, users. All right, now I gave it the password. And it still can't find it, so what have I done wrong this time? Users, Sambound, 128, 121-demo. I spelled tar wrong, TQR, I can't see what I'm doing, I'm spelling things wrong, right? So TAR. All right, now the password. Now it's moving, and notice how fast it moves. The other one was going to take like a half hour, and it's already 50%. This is taking like 10 seconds. So this is the boss way to do it. All right, now I have the image on the, in the default directory here. Now I'd rather have it on my desktop where I can work with it. So let me go to my desktop and delete the stuff I made earlier today. I'd like to throw it away. Microsoft has hidden that because all they ever do is hide everything good. Delete, okay. All right. Most everything in the right-click menu is now on the More Options menu because Microsoft loves to torture us. All right, so now I can move Android image to desktop. All right. And there it is. That's the image that I got from the phone. Now we're just going to analyze that in Autopsy, but I think we have to unzip it first. This is a tar.gz, and you can unzip it with 7-zip, although it's, of course, hidden on the More Options because that's Microsoft for you. So 7-zip extract here. That will unzip it. And you have to unzip it twice. It is a tar.gz. The tar is a file that contains many files without compressing, and the GZ compresses it. And in Linux, it's done in 2 steps. So you have to unzip this gtar file to get back to the data folder. There. So what I've got here is all the files copied from the phone, and now I can just analyze them with Autopsy. So, start up Autopsy, and let me try and find my instructions. Okay, and here we are. Good. All right. All right, new case. New case, I say? Okay, good. Now this is 121 demo. Next. And finish. All right. To create the database or something. Oh, good. I see the OBS is actually getting my whole screen now, not just the top bit. That's nice. A feature of using this different room. And something failed about the keyword search module. Apparently, it doesn't present what we're doing, but appear to be a couple little things broken about it. Is this a method used in evidence acquisition for investigations? How do they make sure they're not? Well, these are good questions coming. Yes, you can use this method. Now, what people often do is pay for expensive tools that do it automatically. But this is one method you can use a lot of different ways. How does an investigator ensure they're not putting new data on the phone when acquiring root? You are. You are putting more data on the phone, and copying into an image on the phone is very unprofessional. That's what I did here. I tried a lot of other things first. It's much better to copy directly over the network to another device, but I couldn't make that work. So you are modifying the evidence when you do this kind of acquisition. This is a live acquisition from a running device, and you always modify the evidence when you collect it that way, and you just have to know that. So it is, you will have to know what what changes you made. This image is going to include that magisk that I put on there, so that's not something the perp did, that's something I did. All right, so now I have next at the start here to generate a name based on whatever, and now logical files are what I want. So next, and now I add those logical files from my desktop. So I go to desktop and select the data folder, select, and then next. And now, I've already done it on this one. I don't want to do any of this except the Android analysis. Otherwise, you'll just waste time looking for stuff like Windows registry in there that is not there. All that I care about is Android Analyzer. And then next. And it will now read all those files from the phone and pick out the Android data it can recognize. Now, a very good question, Mercedes. Real important. We talked about this before. It's good to remember. Logical acquisitions are the most popular these days, but you have to understand what you're doing. We're no different than any other forensic examiner now, where the process of examination does alter the evidence. And that just means we have to be more careful in what we do. So I think that's it. Let me get my instructions back again. All right, now you should be able to find that SMS message on there. And it's here in Data Artifacts, Communications Accounts, expand that. And here you see Device and Phone. And if you click the phone, you'll see here I have a couple of phone calls. You see from there to 111, 222, and if you click on them, it'll show you, I think these are the SMS message. Yep, here's the SMS message. Someplace down here, and I think you can see the actual contents of the message somewhere, but maybe not. I think before I somehow found like the hello message, but this time I'm not seeing it. Anyway, I think that's why I made the flag just something you can easily find. I had trouble finding the contents of the message, although I think it is in there somewhere, maybe up here. Yeah, it's showing me stuff, but it doesn't, Android message, I think it might be over to the right somewhere. It isn't showing me the actual message, which is annoying. But I think I was able to find it before, somehow. But I'm not having any luck finding it now. But anyway, that's all I wanted to show you. That's the steps. And I realize getting ADB connecting might require a little more work. So people who are doing this might want to ask me for help, and I can help you. The problem is as it always is, it's getting the path right. All open source products never fix the path on Windows for some ungodly reason, and you have to manually fix it. It's worse with Java, but it applies to almost everything. So you get used to solving this. It's like a little puzzle every time. Yeah, Joe Dirt wants to talk about Mercedes questions again. Whenever you do a live acquisition from running device, you are contaminating the evidence. Just like if you have blood spatter and you swipe it up with a cotton thing, you're changing the evidence. So you have to understand that what you've got now is an image of a phone that had the suspect doing stuff on it, and then there came a time when I did stuff on it. So when I analyze all the actions that have been done on that phone, I'm going to know what part they did and what part I did. One simple thing is, of course, to just do it by time. I record the date and time I start my examination, and anything that happens after that time is me, not the suspect. The only reason this even comes up, and it isn't just obvious, is because there was a time when everybody would just turn off the power and then get a hard drive, a static image of the hard drive. And then you'd get a perfect image, and 100% of that data came from the criminal or the suspect. You never had to worry about anything else. And that only works for the hard drive. And now that we need the RAM for almost everything interesting, you have to give up that luxury. And now you'll have to accept that the process of examining does change some things, and you just accept that. So you know, if you do find, you do not say the suspect rooted the phone, because unless I find that they did it earlier, they didn't. I rooted the phone. So that's not interesting. Now that'll be in my methods. I rooted the phone, then I took the image. I'll explain that I did that. So when the opposing examiner finds this rooting tool on there, they'll understand how I got there. But that's not evidence of what the criminal did. That's a procedure I used to get the image. And any way you get a logical image will have some effect on the phone. So that's why you always record what you do and put it in your appendix, so the opposing examiner can look at your methods and understand what they did. And then, if you did something sloppy and did more damage than necessary, then you may have to defend that. They'll say, why did you do it this way when there was a better way? And then there's an argument over who's the better expert, and that's part of the game. Is there a way the suspect could lock root access to protect this access? Yes, probably. I haven't heard of anti-root software, but it probably exists. There's certainly a variety of anti-forensic software, by the way. There are anti-forensic products that break forensic tools. The simplest ones are zip bombs. You can construct a file which will unzip to something unthinkably huge, like 1 million terabytes, so you'll never finish, and any tool that tries to unzip all the files will just freeze. And that will kill Encase and FTK and a lot of tools. There's a bunch of ways to put files just to impair forensic examination. Now, there are ways around it, but a low-level examiner just trying to run a default tool will find that it crashes. And there are also ways to encrypt data with layers of encryption, so even when you think you've decrypted it, there's another hidden layer underneath it, and things like that. There's ways to hide data so you can't find it with forensic tools. But you very rarely see that fancy stuff. But it can happen. It's a very good question. Anyway, let me stop the recording. Find my device. All right.